Sn. So you should know S3 is 6, S5 is 11. Find the value of P and Q. Okay, this is not too bad lah. This one just substitution, right? N equals to 3. S3 is equals to 3P plus Q3 square. So then we know that S3 will be 6 equals to 3P plus 9Q. This is the first one. N equals to 5 will be S5. 5P plus Q5 square. This will be S5 is 11. 5P plus 25Q. Then you just solve this one. Simultaneous equation. Okay, got this. A part 2. What do you do? A part 2. Deduce, find otherwise the expression of n term. N term UM is Sm minus Sm minus 1. Okay, then we're just going to use the formula. What I like to do is to just keep the P in because and the Q in first. I don't want to substitute the value as 17 over 10 and also 1 over 10 because it's going to be very, very, very messy. Okay, so I'm going to just do this, then just simplify this guy here. This is my Sn, this is my Sm minus 1. So this one I'll cancel, this one will cancel out as well. So I will left with this guy. This is what I will do because I don't want to keep writing 17 over 10 and 1 over 10. I'll just write P and Q first. Then with the previous answer, this will be the n term. At least that's my n term. Nth term. Okay, common difference is un minus un minus 1. Okay, common difference AP the common difference. So you take the current term minus the previous term, you get the common difference. Okay, so this will be 1 over 5n plus a over 5 minus 1 over 5n minus 1 plus a over 5. Let's go. So set a value this interval such that the sum to infinity of a GP. This is GP, right? So this is GP here. 1 plus sine theta plus sine square theta. Now we try and understand the GP. First term is how much? 1. The common ratio is sine theta. So for sum to infinity to exist, mod r is less than 1. So you have mod sine theta is less than 1. Okay, how do you solve this? This guy here will be between minus 1 and 1. Okay. Now this is sine theta is you draw the graph, will be easier to solve. Okay, you don't try and solve it like you can't solve it algebraically because this is not a strictly increasing function. This is not a strictly increasing function. Okay, you can't. What I'm saying is you cannot sine inverse like that. You can't do that. This is wrong. You can't do that. Okay, because the sine graph goes up and come down. Goes up and come down. So when you draw the sine graph, remember you use a GC, right? This is from you're looking at this interval, negative pi over 2 to pi. So how does the sine graph look like? This is your sine graph, right? So okay, you can key in calculator. Okay, remember this. You key in calculator sine x. For the domain, this is what you do. You put divide open bracket. Okay. Then I put minus pi over 2. Then I put second test. I go to condition. I put number 5. So put this then you put pi over 2 behind. Okay, this is how you key in your G. So I repeat, you put divide open bracket, but you put minus pi over 2 like that. 2, right? Then you put like second test, you go to condition, press number 5, then you put pi over 2. Okay. Second test, go to condition, change it. Then when you graph your graph, once you're done, you'll be like that. Okay, but I mean this is a sine curve which you know. Oh, but it's a strictly increasing function, so it's good. So this one, sum to infinity exists. This will they never ask us to find the range of theta but anyway, for the range of theta, in fact, this is the sum to infinity Okay, so this is not the what they want is sum to infinity to be greater than 2, right? So this will be 1 over 1 minus sine theta greater than 2. So this guy, oh, this is tough. So 1 minus sine theta minus 2 bigger than 0. Then we need to, I think, just use a graph to solve this. Use a graph to solve this. This one, I'm just gonna use a graph and solve it. So this is or rather I could just solve this one. I let this be my y1, my y2. So you put the graph here. 1 minus sine theta. Then this guy you put 1 minus sine theta. Then the other guy you put 2 lah. Okay. Then you just graph it. Okay, you want it to be more than 2. So you can actually, they never ask for exact, right? Okay, well, exact, good. Set of values, okay, can. So set of values, we need this to be between minus pi. So I'm gonna put the domain again. Negative pi over 2 to pi over 2 lah. Key this in. So this is my graph. Oh, there you go. You want it to be more than 2. This is y equals to 2, right? So essentially your set of value should be this guy here, 0.523. Okay, you can, they never ask for exact, so I'm going to use GC. So set of value of x. Then you get 0.524. You want more than, greater than 2, right? So less than pi over 2. Because we stop at pi over 2. So actually the graph, if we can, we zoom, yeah, pi over 2. Yeah, this one goes all the way to infinity lah. So we get here to here, this portion. Just from GC enough really. Yeah. So actually this region here will do. That's all, yeah. We don't need this working. So just now I was like, yeah, we don't need to show that the sum to infinity exists. We just need to show this inequality here. That's all.